Go for it.
Awesome. Hello and welcome to the Cambridge Skeptics live stream. My name is Erica and I am here today with Andrew, Chris, and Sam. The Cambridge Skeptics are a volunteer organization. We're dedicated to promoting critical thinking, science, and positive skepticism in our local community of Cambridge, but also across the UK and beyond. Today, we are here to discuss flat Earth belief, something that is close to all of our hearts in the sense that we all live on the Earth. Andrew, why don't you introduce this topic to us?
Thank you. So yes, going to be looking at.
Sorry.
We're going to be looking this evening at why people believe the Earth is flat. So I want to say from the outset that my aim this evening is not to make fun of people. I'm not going to spend the next hour calling flat earthers stupid. If that's something you've come here to see, I apologize. There are plenty of other YouTube channels out there that will do that for multiple hours for you if that's your thing. I'm also not going to spend that much time looking at flat earth arguments. The main focus this evening is going to be sort of their philosophy, their psychology, and their approach to science and why they come to the conclusions they do. To start with, right off the bat, I want to ask my fellow panelists, can you tell me why you believe that the Earth is a globe?
Because I had a globe as a child. That's how they got to me. It was Big Globe.
Big Globe, yep.
Big Globe.
Chris?
So what sort of direct evidence do I have? Is that what you're asking?
Well, yes. I mean, the reasoning you have. So when someone says what shape is the Earth and you say it's a globe, how do you know that?
Well, I guess primarily through expert consensus. But if you want to know what evidence I personally would draw on, as you know, I spend a lot of time at sea on boats. And I know that when you're approaching the land, the top of the land appears first and the shoreline appears last, which seems to conform to what you would expect from the globe model. Another thing, when I was young, I traveled overland from London to Sydney. And as I was traveling along, I could see, for example, the orientation of the moon changed as I got closer to the equator, and then continued as I continued south. And I saw the Polaris vanish from view and the Southern Cross come into view as I traveled south. So those are the main empirical evidence I personally would draw upon to support my view.
Fair enough. Sam?
Well, I think I first was got by Big Globe like Erica, but after that, yeah, it was the kind of the space angle, learning about the planets and seeing footage and images, and I mean, ultimately, the footage is pretty, videos and whatnot that we've got from the from various spacecraft is pretty clear. And you've got to remember how rubbish photoshopping used to be. Like, okay, yeah, we've got deep fakes and great skill now, but it used to be absolutely rubbish. Special effects were awful. Like the idea that this could have been somehow constructed is mad. Not that it occurred to me at the time that it could have been constructed. I had no doubt that what I was seeing was real.
Yeah, fair enough. So, I mean, I'm in the same sort of position, to boil it down, I suppose people told me it was a globe. I had no reason not to accept that it was a globe. And the few things that I could do myself seemed to confirm that. And yeah, space, pictures from space and things like that. So all of those things are pretty much things that flat earthers question, and possibly with good reason. And that's what we're going to come to a bit later on. But before we sort of get started on that, one thing I want to look at is why flat Earth is becoming so popular at the moment. Just a couple of decades back, nobody was really an out flat earther. It's a fairly modern phenomenon, and so we'll have a quick look at that. I'm going to basically speed run the history of the flat Earth movement. I've put a link in the description to a video by Michael Marshall, who does a much more in-depth history than I'm going to go through. But effectively, it starts with Samuel Rowbotham in 1849 with the publishing of his Zetetic Astronomy. So basically, Rowbotham had an issue with the scientific method. He didn't like the conclusions that it was coming to related to a number of factors like the shape, the age of the Earth, evolution, all of that sort of thing. And he came up with an alternate approach to science, which he called Zetetic Astronomy. He then used this approach to carry out measurements of the Earth at the Bedford levels, which we all went to a while back and carried out our own experiment, which we'll show some results of later if we have time. He concluded the Earth was flat. So after his death, another group of his followers formed something called the Universal Zetetic Society. This in turn became the International Flat Earth Research Society, then the Flat Earth Society. There was a fire in their office. The Flat Earth Society died effectively because they lost all their records. And then in 2004, it found its way onto the internet as an internet forum. And around 2005, I discovered that and started debating with flat earthers something like 16 years ago now. It really got a big boost, though, in 2014 when it popped up on YouTube. And in the first sort of pro-flat earther videos appeared around then. Then in about 2015, some of the bigger channels started putting out content, which really gave it a boost. So you have Mark Sargent came along with his flat earth videos where he'd lay out some of the arguments, most of them put forwards by people like Samuel Rowbotham. And then the big one was sort of Eric Dubay, who came along with his 200 Proofs the Earth is Not a Globe, where he hit on a sort of magic formula of memifying the flat Earth. So he took the arguments from the, Mark Sargent's sort of long form arguments and brought them down to the Earth looks flat, therefore it is, water is always level, that sort of thing. And, people started spamming these over social media, and you could really quite easily remember dozens of arguments for the flat Earth in a few minutes. They became really simple things to put out.
I have a contribution. I just did a quick Google Trends search of flat Earth data over time, and you can see exactly what you were saying, that it's really after 2014 into 2015 that the trend in terms of Google search terms starts to kick off. That's all.
Thank you.
No
That's
problem.
great. I did have that graph somewhere, but I gave up doing a presentation. That was too stressful. So
that's what our team.
Around 2016, the rapper B.O.B. Posted to his, I think it was 2.2 million subscribers on Twitter at the time, some sort of pro-flat Earth tweets, basically just sort of questioning, if the Earth is really a globe, why can we see this place from here? Neil deGrasse Tyson, popular science popularizer, with, I think he had something like 45 million followers or something stupid like that. He responded. The two of them got into a little bit of a back and forth that ultimately resulted in both sides rapping about the subject. And pretty much overnight, flat Earth went viral. It was everywhere. It was in the news all over social media and stuff.
So you're blaming Neil deGrasse Tyson?
It is Neil deGrasse Tyson's fault. If he kept his mouth shut, this might not have happened. So that effectively brings us up to date. We've had flat Earth documentaries on Netflix and all sorts of things like that. But I think that actually only answers half the question. That is, the history of the flat Earth movement explains why it was in the public consciousness when it was, but why it was actually adopted by so many people at the time it was is another question. And this is one which I've been thinking about quite a lot, and I don't have any real evidence to back it up. But I think my analysis holds up quite well. And the thing you have to remember is ultimately flat earth belief is a conspiracy theory. That doesn't mean that all flat earthers are conspiracy theorists. They don't all believe in that. Some of them are religious. Some of them just may believe for different reasons. But at the end of the day, the flat earth is an attempt to explain aspects of the world in a way that includes a secret plot between two or more powerful actors for unknown and possibly nefarious purposes, which, if you remember the talk I gave a few weeks back, is what a conspiracy theory is. And with that in mind, you can look at it in terms of what makes people believe in conspiracy theories. So there are a number of strong psychological motives for believing in conspiracy theories. And some of them are things like ways to make sense of stressful, contradictory, and uncertain situations, to help deal with sort of large scale events that are going on, to give people a sense of control when they feel powerless, and to feel that you have a knowledge that other people don't. So, Erica, could you bring that graph back up again if you have it at all?
Yes, I do. Yes. Share a tab. There we go.
Marvelous. Okay, so the question I want to ask you is, do you guys remember what was happening around 2015, 2016 in the world at the point where people started adopting belief in this new popular conspiracy theory?
Donald Trump.
Donald Trump. So major political upheaval in America, lots of people very unhappy with the situation, looking for something new, looking for new answers to old questions. So, and in the UK, we had Brexit, the same sort of thing. You had a lot of stressful, contradictory information flying around. You had uncertainty about how the future was going to be. You had...
and we'd had enough of experts, if I remember
yes,
correctly.
we'd had enough of experts, yes, all of this stuff. And so it was very much the perfect environment for people to latch on to alternative explanations, different ways of viewing the world, and ways of reducing their stress, reducing the anxiety caused by all this thing by latching on to conspiracy theories. And yeah, so I mean, like I said, I don't really have anything concrete for my argument. There are a number of papers out there that compare people looking at looking at searches for Donald Trump, Hillary Clinton, all of that lot, and comparing them to a number of searches on the flat Earth, and the arcs that you see are very match fairly. It's a lot of correlation at this point.
Well, I think it is sort of well established that when people feel uncertain and fearful,
yeah,
they do tend to they do turn towards conspiracy beliefs. That is established. There's still a little bit of question as to whether these uncertainties cause these conspiracy beliefs.
Exactly. The fact that uncertainty and all that lot increases people's belief in conspiracy theories is fairly strongly established. It's just, like you said, whether these particularly uncertainties are to blame.
We're still in very uncertain times, and it looks like that graph is dropping off. Is that because they found other conspiracies around certain viruses that are around at the moment? Or?
I think that might be because of the response on YouTube. So, as I'll come on to later, YouTube played a very significant role in the rise of the Flat Earth movement. And since then, they have taken steps to reduce how readily available flat Earth content is. There are loads of channels debunking it. You search on Google or any of these platforms for information on flat Earth, what you get first is the arguments against it.
Yeah, I was doing some searching for this talk, and the
pro
arguments are a long way down the list. If you can get that far.
It's quite hard to find the pro arguments. I mean, I've been trying to watch as many pro flat Earth videos as possible, so I could understand where they're coming from. But it's difficult to find. So with my speculation out of the way, before the next question we really need to have a look at is, what is it that flat earthers believe? And this is actually quite a difficult question to answer, because there isn't a standard flat earther. The analogy, which I think works quite well, is that it's kind of like the Christian religion, in that there are loads of people who will happily identify as a Christian, but you know that the people who are in the Catholic Church will believe things that the people in the Protestant Church don't believe. The fundamentalist Baptist Church in Kansas somewhere is going to have different beliefs than the Church of England church down the road from where we are.
Is there a flat Earth version of the Jehovah's Witnesses, or is it just like, yeah, you know what? There's this completely other.
Yeah, well, in a way that there is. It's the beliefs that they hold are very often very different, and there are such things as heretics within the flat Earth movement. You know, there are people who are labelled as sort of, controlled opposition. These are people who aren't real flat earthers. They are paid by the government to spread misinformation and things like that. And you see this with, for example, mentioned Mark Sargent earlier. He was a very prominent and very influential flat earther. He appeared in that Netflix documentary. And because the Netflix documentary made flat earth look somewhat ridiculous, he was immediately labelled as a shill, as a.
He did an advert in Australia that made fun of flat Earth as well, didn't he? If I remember.
Yeah, something like that, I believe. Yeah. But yeah, he's now, a lot of flat earthers don't believe that he's a genuine flat earther, that they will oust him. But with that in mind, there are some general areas. So I'm gonna have a quick look at some of like the flat earth. I use the word model very, very usually. They're not scientific models in the way that we would understand them, but they attempt to explain how the world is from the flat earth point of view. So the first one I want to look at is the one that's most connected with the flat earth society. And this is a disk in space, and it is accelerating upwards to because upward acceleration would have produced the same effect as gravity, even because they don't believe that gravity is a thing. Now, this is one that's very much fallen out of favor. The Flat Earth Society is one of these groups that is generally viewed by the Flat Earth as a whole as a controlled opposition thing. And the thing is, I actually think they are kind of right. Not in the sense that this is a government group, no, the government aren't sponsoring these people to spread misinformation. It's just the fact of the way that the Flat Earth Society has evolved, especially on their forum, in that it's kind of been taken over by people who don't believe the Earth is flat, but want to test their argument and debate skills by, supporting a position they don't hold. So you have a lot of people come onto the Flat Earth forums who are physicists and, have qualifications in these things, who try to make the most convincing argument for a flat Earth that they can. And because they are not flat earthers, they aren't, singing from the hymn book, so to speak. They are coming up with their own ideas to try and things. And they often present ideas that are generally not held by the flat earthers as a whole, such as the upward acceleration or the disk being in space. Most flat earthers don't believe that the Earth is a disk in space. They don't believe in space. Space is not a thing. So this brings us on to the next model, and that is a disk with a dome over the top of it. And the dome is generally referred to as the firmament, which is something you find in the Bible and some other religious texts. And the sun, the stars are in the firmament, the sun and moon travel round above the surface Earth within the dome. Outside of the dome really isn't a sort of question, that there's no sort of beneath it. It is a self-contained unit that exists somewhere. There's no real clarity on where people think it is. It's just a thing that's there.
But okay, I know you've just said there's no beyond the dome, but what's beyond the dome? Like, is it space in the sense that there might be other domes elsewhere, or that there's nothing, or is it just that the edge of the dome is the edge of existence? Is it like, oh, God's created the earth and the firmament to nothing else?
You have this idea in some ancient religions of sort of the waters above the dome and below the dome. So there is something beyond the dome, but it's not anything we could reach. It's not space. There's not other planets out there and stuff like that. It is just another a place. There isn't really any consensus on what people think it is. I mean, for want of a better argument, it could be, Earth is a snow globe sitting on God's desk. You are in heavenly space, if you want to sort of, you're talking in a, it's very much a supernatural realm. But yeah, like I said, there's no general consensus that I've come across as to what's outside the dome. It's generally not a question that seems to be addressed that much. It's like, we don't know. Flat earthers are happy to say we don't know about some of these things. It's a thing they don't know, and it's a thing they don't think it's possible to know in most cases. The other main model that I want to look at is the endless plane model. So in this case, you have, again, Earth is a circular disc with the continents in it and the water, and then you have ice around the outside. But rather than just being like an ice wall, where you, in the other two models, where you reach the ice and then there's either empty space or the dome, here you have an endless plane of ice. Ice stretches in every direction endlessly, bisecting reality, top and bottom. There's this endless ice plane, and possibly elsewhere in this plane there are other puddles where there are continents and life forms and things like that. So those are the three most popular things. I'd say arguably the dome and the endless plane are the ones that get the most traction. There are a few others. You have Pac-Man Earth, which is an interesting one, where you have, generally they view it as a square, but much like Pac-Man, you go off one side and you come in on the other. The interesting thing with that is that obviously if they mapped all the points where you came off and where you came back on and then joined them up, you'd end up with the globe. So there's people who support that idea. There's the ring system, where you have Earth in the middle, and then you have a bigger ring round that. So you have the ice wall around the middle of like our bit, then a bigger ring round like that, with more water and more continents, and then another ring round that. So like tree rings, it expands, and they believe it expands from where the North Pole is, and that at some point in the future it will expand again and will get pushed out into one of these outer rings.
Is that the one with the weird egg theory on the North Pole?
Yes, that is part of it, I believe.
Was that variation?
It's not one I've looked into that much, because it's very much a
niche,
a belief that's kind of a niche belief within this niche belief. There's another one, which is one I came across recently, is the atom theory, which is where the whole universe is toroidal fields, and everything is based on the structure of an atom, with like the Earth as the center and things revolving around it. And I don't really understand.
Aren't atoms sort of globe shaped?
Yes, except so they have this idea that you have the flat Earth circle in the middle, then you get the toroidal field comes out and in like that. So it comes in goes out the top and in back in through the bottom. I don't really understand that one. I'll be honest with you.
But the summary is that,
I was gonna say, how do they explain gravity? Like in all the models, like obviously the acceleration one.
Gravity.
But
gravity doesn't exist. So, that's basically how they explain it. Gravity doesn't exist. It's density and buoyancy is the general argument given, which ignores the fact that gravity is part of the buoyancy equation, and it doesn't make sense, because there's no
I mean, if it
no
made sense,
vector involved. That, you know, you have, so this is more dense than the air below it. So the argument is it falls, but it's also more dense than the air above it. So why doesn't it go that way? So there's no, the answer you often get in terms of vector in that is I lifted it from the desk, and in doing so, I gave it a certain energy attraction back to where it came from.
gravitational.
So it wants to return back to the desk.
Okay, but if you pick an apple off of a tree and pull it down and then let go, it doesn't go back to the tree.
No.
Sorry, just
but the argument is very much the vector is all in one. You know, things fall down because they do is effectively the answer.
Okay, but then, yeah.
So with all those different models on the table, the question becomes, you know, what do flat earthers have in common? And generally, if you want to boil it down to one or two things, it's simply, we don't believe the earth is a globe, and we have a mistrust of science. Why I'm using those two fingers rather than these two, I don't know. That's a weird way to count fingers there.
German.
They have this general mistrust of science, and they don't accept the globe model. A lot of flat earthers will say that they don't know what shape the earth is. They don't know how it works. They don't have a map of the flat earth. They don't have any of this information. All they know for sure is that the earth is not what we've been told it to be. And this sort of brings us on to...
Seems very much like anomaly hunting, which we saw in conspiracy theories. You just look for what's wrong. You don't try and explain it other way.
Yeah, it is very much that, and it often has a lot of bias and shifting of the burden of proof things. I mean, a lot of flat earthers will go out of their way to say things like, I'm not making any claims about the shape of the earth. I am simply questioning what we've been told, and I'm finding flaws in the things we've been told. It is often as I said, it's questioning the established answer without actually trying to put forwards an answer of your own. I'll come on to a bit more of that in a bit, but so this sort of leads us on to sort of flat earth epistemology, and, you know, how the sort of questions they have and the way they start their thinking. So you have things like some of the things they think are, you know, science is not capable of demonstrating the earth as a sphere without the use of all this complex technology, like, you know, measuring gravity waves and pictures from space and stuff. But the spherical model was developed before we had all this technology. So they have this, well, how can that be? You know, how can we trust that what they're saying? It seems to me like they've come to an answer first, and then they've tried to develop technology in complex ways of explaining this. And we've got some good comments in the chat.
What I think saying about the circumference of the Earth, that addresses kind of the radius of the Earth question.
Yes, the radius of the Earth question is a great one. Please check the comment.
Chat
box
description. Yes, you'll find a link to a video where the four of us went out and took part in an experiment to measure the radius of the Earth. It was great fun. We really enjoyed going out doing that. And that's an experiment that we did ourselves. We went out and we measured the angle to the sun. And actually, do you know what? I'm going to share my screen. I wasn't going to do this, but I'm going to do this now. This is something that somebody has done. A chap called Ion has taken the data from the experiment we were a part of. So this is the data from the experiment, and it is projected on a flat surface.
Can you explain what we did for the experiment?
Yes, sorry. So basically, for the experiment, we went out on the solstice and we measured the angle to the sun using a stick. So we placed a stick in the ground, we measured the length of the shadow, and from that we could work out the angle to the sun. We then sent all the results in from, you know, lots of people around the world. This experiment. A chap called I Can Science That gathered all the results together, and these are the results projected on a flat Earth. And as you can see, there's lots of crossing as so trying to work out where the height of the sun is. So on a flat Earth, this information would give us the height of the sun. So it could be kind of around here, but you also have a sort of gathering of data over here as well. I don't know, I assume you guys can see the mouse.
Yeah.
Now, what I like about this person's projection of this is this allows us to take this data, and by dragging up, we can change the surface of the Earth from flat towards a globe. And if we drag it all the way into a circle, we see that suddenly, rather than having contradictions in the data, all the data makes sense. It's all parallel lines pointing towards a distant sun, and it all has consistency. So this, to me, is a question that needs to be answered. You know, if the Earth isn't a globe, and let's say it's not, if the Earth isn't a globe and is indeed flat, why is there inconsistency in the data when we map it on a flat surface, but there's not inconsistency in the data when mapped upon a globe? Regardless of what the radius is, regardless of how big it is, the shape is a globe here, and the shape is flat here, and the data has problems here, but not as a globe. So let's say the Earth is flat. Why does the data play out like that?
I was going to ask you, like, based on your knowledge of the psychology of conspiracy theories, how would someone feel if they were deeply invested in a flat Earth belief when they were confronted with this data? What sorts of things might they react with? So,
thank you. Multi-Tom has actually given us a really good response. I'm really glad you're here. It's nice to have someone who is a flat earther in the chat. I really appreciate it. He's commented that to measure the ground, you don't look up. So, which is a common flat Earth argument. You know, we're looking to see what the shape of the Earth is. Why are we measuring angles to the sun and things like that? It seems counterintuitive to look in the opposite direction to where you'd want to find out the answer. It's not. It's, you know, it's geometry allows you to do things like that. You can, I mean, it's about maths and geometry are not anywhere near my strong point. I could not explain the details of that.
I have a maths degree, so
Sam probably could, but yeah, you don't need to look at the surface you're standing on to work out the shape of it. You can use observations you make from that surface to work out.
Well, if we had a giant ruler, we could measure the size of the Earth, but we don't. So
plus rulers flex, so it'd be a bit difficult. So
rulers flex.
Yeah.
No, but there is within trigonometry, in order to determine the size of a triangle, you either need two angles and a length, or two lengths and an angle. With those, you know, with those things, you can work out the shape of the triangle. And so, in this experiment, we have two angles and a length. We have the angle in one point, we have an angle in another place, and we have the distance between them. That gives us two angles and length. And so from that, we can determine how far away the sun is. In this case, because we've got many observations, we can determine, you know, if we just had two angles, we could say, well, either the Earth is curved and the sun is this sort of distance away, or the Earth is flat and the sun is this sort of distance away. But by then having a third one, it then creates a third measurement. It then creates conflict because you can create three sets of triangles, any combination of distance between 2 points and the angles of those 2 points. And so, yeah, as we're seeing here, you look at any two lines there, that forms a triangle. And what we're seeing here is two sort of regions where a flat Earth would put the sun, but they are massively varying in terms of exactly where you would put the sun. Whereas when you put it back to the globe Earth model, actually, those are all pointing off to a single point in space. They're all reconciling with each other. They all are consistent. And these are measurements from dozens of people all over the world, rather than just, you know, a handful, you know, a single body. And the fact that, actually, as it's explained by Icon Science that in his video, the margin of error on the measurements under a globe Earth model is very good. Like it's very small, and all very consistent. Whereas the different measurements you get in terms of the potential height of the Earth vary, I think, by an order of magnitude. It's like, oh, it might be 1,500 kilometers above the surface, it might be 15,000 kilometers above the surface, but they're deeply inconsistent.
Yeah, I don't think it was, I think it went something between like 5,000 and at the high end, and like just under 3,000, if I remember. It wasn't as big as that, but it was, yeah, it was a big margin. You was, doubling in some.
In any case, the angle measurements must have been massively off. People were basically just not looking at the sun, just going, yeah, sort of in that direction, rather than taking a measurement if flat Earth were true. So it's all the measurements that we have are consistent with the globe Earth.
Yeah.
Well, all the measurements we've taken in this experiment.
Yeah. So
specifically this one.
The question I would ask from then, as I said before, is how do you explain that data? How do you explain the inconsistencies when it's plotted on a flat surface, but the consistent data when it's plotted on a globe? Forget the size of the Earth. Let's not worry about that. Let's just the shape. Regardless of the size or anything like that, which we can get from that data, the shape of it alone has, one model has inconsistencies and the other one doesn't. Anyway, moving on, but talking about the sort of epistemology. One of the other things is, you have claims such as the organizations like NASA claim to have experimental evidence of the shape of the Earth, but they're not trustworthy. And they have this view that NASA has lied about other things. Maybe there's a lot of flat earthers also believe that the moon landings were faked, mainly because space is not real. And
doesn't
the whole
exist.
thing ties together. But if you don't have space, then the moon landings are fake, which means NASA cannot be trusted. So when they are probably the biggest voice most of us hear talking about the Earth being a globe, you can completely understand why people would go, I'm not buying this. Another sort of epistemology.
I have a question about that. So like I have a friend whose sister works on picking the locations for Mars rovers. She's an extraterrestrial geologist. What do they think that all of these people in the space industry do?
It is a good question. I mean, one of the things that often comes up is about the amount of money that NASA gets. But once you look at how many people work in there, the number of other contractors they give money to build things for them, it's difficult to understand what the motivation is from a financial perspective.
I've seen them claim that people like your friend are generally naive about what's going on in NASA. They're performing their job and they don't know that the top brass is just taking their information and binning it.
Yeah, but what I mean, that's actually a really good point. The idea that most people in science are much like us. They have been told that the Earth is a globe from an early age. They've maybe heard information from NASA, but they don't really know the truth. But the problem I see with that is, I mean,
if it's for the money, why is NASA spending all the money?
I'll give you an analogy. I work for a software company. I don't write the software. I do support for the software. Now, if the people who developed the software told me it did something, and it provided this information, I, using the software and supporting other people using the software, would quickly realize whether that was true or not. I would be able to tell from the information I'm looking at whether what they're telling me is accurate or not. If they say, the software sends out messages or, records whatever, and it doesn't do those things, and it doesn't do them in the way it says, I would notice that. And you have all these scientists working around the world who are building rovers, who are mapping locations on Mars to send the rovers, like your friend. If that wasn't real, then the information they get back from these rovers and stuff, they would be able to tell if it wasn't real. They know the direction and the strength of the signal and where it's coming from. They would be able to tell if it's being beamed from a hot air balloon with a satelloon attached to it rather than from Mars.
So there's a second group faking this information. This works out very expensive.
So if there's a group faking the information, then the people who are receiving that information, either that faked information has to be exactly what they would expect it to be, in which case how the first group would need to somehow know exactly what it was meant to be, and it becomes really complex really quickly. And I think
but there's also some stuff that can be tested without NASA. It's not that. No, not every telescope is owned by NASA. When they went up to the moon, they left reflectors on there, and any private individual can set up a laser and a detector, point it at this one spot on the moon, and fire off a burst, and then measure the response. Whereas if you move slightly off target, it won't.
Yeah, it's a little bit more complicated. I mean, don't want to give the wrong idea, but yes, it is something that is well within the possibilities of a marginally funded group to get a laser powerful enough to do that, and the receivers and stuff like that. It's not out of the possibility of
our friend in the chat has raised a good question, which is like, what's the motivation for these people to prevent us from knowing the truth about flat Earth? Do flat earthers give sort of like a root cause reason why?
So there is a number of common responses. There's financial motivations, such as, for example, the hiding of additional land. So this comes into people who tend to believe in the theories where there's more land beyond the ice wall. A lot of people will say, well, the governments want to keep this land for themselves, so they hide the existence of it. The question that always raises me is, why would they want to do that? Why, what is the benefit? So let's say
it's only valuable if it's put to use.
Something is only valuable if it's put to use. Say I find a diamond mine out there, or oil reserves and stuff like that. The only way I gain from that is if I put that value to use. If I bring the diamonds from outside the known world and start selling them within the known world, and bring the oil in and using it. But the problem with that is that we have ways of telling where diamonds and oil come from. We can look at the chemical makeup of these things and go, yes, exactly. We can go, this diamond was found in this mine. If suddenly a load of diamonds or oil started appearing on the market that, firstly, nobody really knew where it was coming from in the first place, you suddenly have these oil tankers coming from apparently Antarctica and bringing these reserves. People would ask questions. The people who are the experts in this would know very quickly that this is a newly discovered resource. And so that explanation doesn't make sense to me. But I mean, the most common response given is that it's in some way an attempt to hide God or hide our significance and things like that. So if you have a globe Earth in a practically endless universe where we are, a mote of dust in a sunbeam, we are basically insignificant in the grand scheme of things. We're talking natural processes, no guiding hand. All of this came about by chance. We are effectively meaningless. That kind of points to the idea that a God doesn't exist, that there is no grand force behind all the things. However, if you have a flat Earth that appears to defy what most of us would understand by physics, that is covered with a dome, that is clearly an intelligently designed product, well, then, of course, that makes people think about God. That points very much to the idea of a higher power. Again, the big problem I see with that is that if this is the reason, if the reason the governments of the world are saying the Earth is a globe is to hide God, they're not very good at it. We have, I don't know what the latest count is, like 7.5 billion people on the planet, 7 billion of which believe in some kind of God. So if the idea is to hide God, then it's not working. It
also
has failed.
If I wanted to believe in a supernatural power, could I not decide to believe in a supernatural power who has made the world exactly as it is?
Yes. Yeah, which is what most people do. Most religious people believe in a globe. They believe in a universe. Most religious people believe in evolution, Big Bang theory, and all things like that. They don't see a problem with the idea that their God is big and powerful enough to have created this amazingly massive universe, but still care enough to be focused on that speck of dust. You know, we are so important that within this grand universe, we are still the most important thing to him. And, you know, a lot of religious people have that view. And while I get the idea that a flat earth would most definitely rule out, you know, natural causes and would definitely point to a creator, you're still only trying to convince a very small percentage of the human population that a god exists. Most people already believe that. So I kind of want to move on to sort of the reasons why people become flat earthers. We're running out of time.
We might have to do a part 2 on this one.
Might have to do a part 2 just to have all the discussions about things. So there's been a number of research papers carried out where people have been interviewed at sort of some of the flat earth conferences around the world. And they've looked at the sort of common way that people come to the flat earth movement. As I said earlier, YouTube plays a very big role. While some people talk about being introduced to the flat earth by friends and the like, most people find it on YouTube. So again, Multi-Tom-Tom, if he's still in the chat, please let us know if this sounds like your experience of becoming a flat earther. So first of all, you encounter a video on YouTube. A lot of flat earthers tend to be into conspiracy theories, so they often used to get linked from other conspiracy theory videos to something about flat earth. And so they watch these flat earth videos and they're not convinced. They think it's a joke. Most flat earthers, when they first encounter the idea, think it is ridiculous. Just like we do, they think it's ridiculous. But they find it intriguing. I find it intriguing. I think it's a fascinating idea. And so they start investigating it. And in their process to investigate, they come to the point where they're like, well, I'm going to debunk this. This is clearly not true. I am going to set out to debunk the flat earth. And they try to do so, and they fail. They encounter an argument for the flat earth. They're not able to debunk it themselves. And so they become more and more convinced that there's something to this. And it becomes a sort of a building up of evidence, you know, more and more arguments for the globe they're unable to maybe reproduce. You know, if when you look at the globe side, if it requires satellites taking pictures of Earth to show what shape it is, that's not something you can do. But if on the flat Earth side, it's things like look at the horizon, see it's straight, you know, look how it always rises to eye level, or that water's always flat. These are things that someone can just go do a day at the beach. These are evidence that they can gather with their own eyes. And go ahead, Sam.
Well, no, but this hits on a mathematical concept which I've been struggling to remember the name of, but basically how on very small scales you see dimensionality sort of reduce. Things can appear lower dimensional than they appear. One example of this is, you know,
the Earth is very big, you are very small, I think is the way of summing it.
I mean, there is that, and with an incredibly large Earth, the small part that you can see can appear flat. But at the same time, it's a bit like, you know, we can move, we as individuals can move incredibly far in 2 different dimensions and very little in one dimension under our own steam. I can jump maybe a couple of feet in the air. I can't move very far, but I essentially exist in a 2-dimensional space. And because I can't, nearly 2-dimensional. And there's the same sort of thing where actually, because you've narrowed it down, things appear to have less character, texture, whatever, because you're just looking at it on a very small scale.
Yeah. I mean, there's some quite nice videos out on YouTube where people have like zoomed in really close on like basketballs and things like that. And they appear perfectly flat. But when you pan the camera out again, you see that it is a circle. but yeah, my point was that people become convinced because they fail to debunk the evidence. They take a skeptical approach to these things. They take what they believe is a rational approach. I am going to look at the evidence that says the earth is flat, and I'm going to show it's wrong. I can't show it's wrong, therefore I should accept that it's right. And there's actually quite a rational approach. I'm not going to fault them for doing that. Which brings us to something which I mentioned earlier about the thing that Samuel Rowbotham came up with, which is zeticism, or the zetetic method. And this was his response to the way science worked. He had philosophical and other motives, I think, for not liking the way science was working. And so he came up with this different approach. And basically, the zetetic approach is you make an observation, you do an experiment, and you look at the results. And from them, you draw your conclusions. So it is a pared down version of the scientific method. And it leaves out two very crucial steps. So in the scientific method, you make an observation, you do your background research on that observation, you make a hypothesis, you then test your hypothesis, and then you look at the results and draw your conclusions from there. And the reason it's very important, those stages, is so, for example, let's say the boiler in your house breaks. Your observation is that the boiler is broken. It's not heating up the water. The zetetic approach would then say you do an experiment. So my experiment is I hit the boiler with a hammer. And the conclusion is the boiler's still broken. So maybe I do another experiment. I take the front of the boiler off and I wash the insides with soap and water, and the boiler's still broken. But if we compare that to the scientific method again starts with that observation. It says the boiler's not working, no hot water. It then does background research. So you might go online and you might look up the type of boiler you have, commonly known problems with it. You might look at whether other people have encountered this same thing and what they have done. And from that, you find out that a lot of people with this problem have realized that the pilot light's out. So you develop the hypothesis. The pilot light is not working. And then you develop an experiment to test that. So you open the front of the boiler and you look at the pilot light. Well, let's say for the sake of argument here, the pilot light is working. Your hypothesis has been shown false. You've actually learned something. You have something concrete from that. You know it's not the pilot light. So you then go back, look at your research again and see that maybe it's the water main or something like that. I know nothing about boilers, so this is getting a bit difficult.
Really well so far. This is bringing up a lot of flashbacks for me.
So you then go back in with a new hypothesis that is the water mains isn't working. You find from your research what you need to do that. You test that hypothesis by turning the water main tap all the way on, and you have the conclusion, oh look, I have hot water again. And this shows the importance of the two steps that are left out of the zetetic method. It's building on the shoulders of giants, looking at the research that's done before, looking at possible explanations so you don't end up basically recreating the wheel every single time you need to do anything, and then making a hypothesis so you can actively rule things out. The point of a hypothesis is to say, this is my idea, how do I rule this out?
It's something I find very curious from what you're saying, is that the zetetic method basically is saying, do everything yourself, but at the same time you can believe these guys, that, or rather you can still take from these guys. So you've got basically what you have is you have advocates on one side for the flat earth saying, here's our body of knowledge that we've built up, and on the other side you're not allowed to use anything except for your own understanding. So it is one against many in a sense, whereas in science there's some things that are absolutely everyone absolutely agrees on, like the globe Earth, and then there are some things that are still in doubt. And so the things that are in doubt, which have different positions, you have camps that are against each other, but they are constantly vying for proof, evidence, and sort of just moving the whole field forward, and exploring things together. The camps are within the observable and reliable data rather than just being separate for the sake of it. But it is many against many, as opposed to this, which is basically what they're kind of espousing, is a one against many approach, and they're the many.
Yes. Yeah, there's definitely inconsistencies in how it's applied. We are running out of time, so I'm going to try and get through as much of this as quickly as possible. So you have this sort of zetetic approach, which basically removes two very key steps from it. The reason that they use this one is because there is very much a focus on only trusting information you gather from your senses. While in practice, that is not always, carried out. That is generally the idea. If I look at the horizon and it looks flat, my senses tell me it's flat. They don't tell me it's curved. I should trust my senses. That's the conclusion I should come to. And
So,
this is where, oh, sorry, go ahead.
So yeah, I mean, recently I was dealing with someone talking about the magnet challenge, who I later found out was a flat earther. And he was using the same process. They didn't have a hypothesis about why you would be magnetic. It wasn't there. They couldn't tell me, oh, there's something in there that makes you magnetic or whatever, or there's something that's metal the magnet sticks to. There was no hypothesis. And they were just repeating the same experiment again and again, where you stick the magnet on and it holds. And there was no attempt to falsify. It was just, we've done this 1,000 times now, and 99 times it works.
Yes. And I think if you have that approach to doing science, it's very easy to come to the wrong conclusion. I mean, because, the person doing that is actually being rational, saying there is something here, the metal is sticking, there is something causing this. What they're not doing is attempting to rule out possible causes, and that's where science over zeticism is definitely an important thing.
Well, it's a difference between science, but something being science-based and something being, let's call it, evidence-based.
Yeah.
The evidence in Chris's example, this magnetic thing sticks to me. Science would go, okay, we'll do non-magnetic things stick to you.
Yes.
If the answer is yes, you go, okay, well, it's not magnetism then.
Yeah, it's not magnetism.
Which is sort of the case, I think.
So there's various different aspects to this. There's the idea that science is not to be trusted. Very quick way to think of this. Okay, imagine you bumped into a friend you haven't seen in 10 years, and they say, and you ask them, what you've been up to, and they say, well, just after I last saw you, I joined a cult. And over the last 10 years, I've been giving them loads of money and spending loads of time with them. And in return, they've been revealing the secrets of the universe to me. I've made loads of friends with inside the cult. I got married to someone inside the cult. I now actually work for the cult, telling other people about their mysteries. Now, a lot of people don't understand.
Tom Cruise.
Possibly, yes. A lot of people don't understand the mysteries at first, but once they have given up me loads of money and spent loads of time listening to my teachings and stuff, they too come to understand the truth of what the cult teaches. If someone told you that, what's the response you'd have?
Back away slowly.
Yeah.
Yeah.
What if they said instead that since they last saw you, they'd gone to university and they'd given tens of thousands of pounds to the university and spent many, many hours in the university learning the secrets of the universe. They made many friends at the university. They're now married to someone they met at the university and now work in the physics department of that university, teaching other people its lessons. People don't always understand those lessons at first, but if they too commit to spending tens of thousands of pounds and spending many hours, they too can learn the secrets of the universe. Flat earthers do not see the difference between those two things. They see them both as a form of indoctrination. And they're not wrong. It is a form of indoctrination, but the problem is with the science thing, it's a form of indoctrination backed up by hard empirical testable science that the people in those situations test for themselves to confirm that they're accurate. It's not
Fun
just...
fact. The root of the word indoctrinate is the same word root as the word doctor, which means educated.
Well, that's very interesting. I didn't know that.
And I didn't study Latin for 4 years for nothing.
but you can understand from that point of view why they would be, why when we say to them, well, this is what science says, they go, well, that's just indoctrination, because it sounds like indoctrination.
So there is a fundamental difference that science makes predictions that the lay people can confirm and that are useful then for producing it. There's no flat Earth or that's going to sound weird. There's no like, flat Earth or cult microchip, but there is a scientific, science-based microchip that works and that we can use and see the impact of.
We have the fruits of science. So,
and one example is, there was a prediction from the flat Earth theory of the Earth, which we just saw, which is that if the Earth was flat, the lines would intersect at a single point. That has been falsified.
Yeah. I won't go into what the responses would be to that, because I'm pretty much sure I know what the response would be. But you have this idea of, science can't be trusted. It is indoctrination. You have these ideas of you should only trust the information from your senses. The problem is that a lot of the time they don't take the information from their senses and follow it through properly. So there's sometimes the information requires a level of decoding. So when you look at the horizon and you see it as flat, you go, I'm experiencing that as flat. So you trust that it's flat. But there are situations where that's not very much clear. I'm going to try, I'm not very good at using this computer, let's close that, to try and show you what I mean. So let me just, let me open this, and then I will attempt to share my screen. Go big. No. Okay. Wow. I've lost you now. Let's ungo big. Right. So let's share my screen first, and I'll show you this picture here. So this is a picture of a couple of towers. I do know the name for it, but I can't remember it right at the moment. And when we look at this, we see that they are angled, and our brains go, they are both angled the same. They look at this and they say these two towers are angling up the same. Now, if I close this picture and try not to, I've unshared my screen, that's great. And I open a second picture. Now, this second picture is the first tower duplicated. I've not modified this image at all. If it's just the same first tower duplicated. But when we look at it, what do you see? The second tower appears at a different angle to the first one. Your brain looks at these, and your brain does the thing where it goes, okay, if two towers are rising up, they should be coming together. They should appear to be coming together. That's how I know they're going at the same angle. These two towers don't appear to be coming together. So therefore, one of them must be at a different angle. But they're not. I mean, if anybody wants to later pause the video and lay something on the screen.
I'm holding my hand out in front of it. Yeah, I believe you.
Yeah, if you put your hand in front of you can see that the angle of the two towers is exactly the same, but our brains don't do that. So this is where the decoding comes into it. We can't just look at that image and go, I see the truth. I see that these towers are at different angles, therefore they are at different angles. What we need to do is bring in the information we know about optical illusions. We need to bring in the information about how we know that sight works and how our brains process this information in order to get to the truth. The truth is they're at the same angle. The lie, it's not a lie, the untruth,
the illusion
is that they're the illusion is that there are different angles. And if that is the conclusion you come to, you are wrong. You are demonstrably wrong. And that's often the problem with just trusting our senses. Our senses require decoding. There is other things that we need to do. I've got two little things I just want to go over to end. Technically three, but we'll just stick it to two.
Just go for it.
So you mentioned about the non-consistent approach with the syntactic method, where there's, we're told that we need to trust just our senses. We need to just rely on our own evidence and stuff like that. But it's not applied consistently. I've linked to a video in the description, which covers this topic very well. And basically, the lady in the video gives something which she calls the soup analogy. So you go to the shops and you pick up a tin of soup. How do you know that it's safe to eat that soup? You don't know who canned it. You don't know when it was canned. You don't know where it was canned. You have no way of directly at that point seeing what's inside it. you do not have any information that your senses can tell you that the soup is safe to eat, and yet you tend to believe that the soup is safe to eat. And the reason you do is because of what you do know. What you know is that in your country, there are laws against selling inedible food as food. You know that if the supermarket was trying to do that and people found out, they would be in trouble. That the people further up the line would get in trouble for doing this. That, you know, if supermarkets sold poison, there would be repercussions. And because you know that information, you can trust that what you're looking at is what it claims to be. Because if it wasn't, the supermarket wouldn't be open. It wouldn't be on the shelf in the first place. And the same sort of thing applies to science. While we all admitted at the start that we accept that the Earth is a globe in main part because people have told us it. Yes, we've done the odd bit here and there, but we accept it because science has told us it. Well, okay, what do we know other than that? Well, we know we live in a society that values scientific education. We know that if you teach people incorrect things, they lead to bad and incorrect outcomes. So we know that the society we live in benefits from educating people correctly, for giving them information that is, you know, truthful and demonstrable in order to go on. We know that when governments and things like lie to people, and they do, I'm not going to say, none of us denying that, and that information comes out, that it causes major upset, that it causes, you know, people in power to lose their jobs. And if, as the flat earthers like to say, it is so easy to demonstrate that the Earth is not a globe, then you would expect that this would be a major upset, that it would cause people to lose jobs. So we know this other information. So even if we personally have not done all the experiments, have not, you know, gone to the space and seen the Earth for ourselves, we can have a fairly high level of confidence based upon our understanding of what we do know in the societies we live in, that they are more than likely telling us the truth. That the truth is more beneficial in this regard than the lie would be. There are some things that I think science fails at, and I want to end by basically giving the flat earthers their dues here. And that's the fact that with science, there are two parts to it. There is the actual scientific method and experimentation, which is empirical, testable, all of that kind of stuff, all the good sciencey stuff that we all go on about. Then there is how we tell people about science, how we share the information. And that's rhetoric and storytelling. So when you look at, all of us, I think, have read scientific papers. And when you read a scientific paper, the first half of it, the introduction, is basically telling you what other people have done. Now, the person writing the paper possibly hasn't done those experiments themselves. They are just taking the word of the other people. And they are asking you to take their word for it, that these other people that they don't necessarily know are telling you the truth. It is kind of like a game of telephone. The message is being passed on down the line, and you're hoping that the information is coming to you accurately and correctly, and that you can trust it.
We're all just eating cans of soup.
Yes, yes. Well, and there is also the other element to it that when we look at stories and rhetoric about the world, we are looking at ways to make the world make sense to us. And as we touched on earlier, when you look at a massive world with a tiny speck of an Earth, it doesn't give people purpose. It doesn't give them meaning. It doesn't make them feel special. But if you bring that back to a different way of looking at things, you look at the Earth as the Earth is the center of the universe. The Earth was constructed by a god on purpose, and it's clear in its design because it is a flat Earth with a sun and moon moving above it. You suddenly make yourself the most important person in the thing in the universe. You have purpose, you have meaning. You may not know what it is, but you have these things, because otherwise, why would a god create all these things? You know, it puts us back at the center of the question. You also have the fact that science is hard. Science these days is ridiculously complicated. Yes, maybe if you sent us back in time to when we were just rolling balls down a ramp, some of us would be, Erica would be able to work out, the scientific equation. I'm not going to claim the rest of us, but
I'd be more and more on the chemistry side, but yeah.
But
can I just say something about this? I was reading this book, Flat Earth, by an experienced science communicator, and I think she makes a massive mistake about the science in this book.
All right.
She says, she's talking about when Leonov did the first spacewalk. And she says the reason he was floating is because he was far enough away from the Earth for gravity not to have an effect anymore. I'm pretty certain that's bullshit.
That's not right.
It's
falling and missing.
He's in free fall, yeah.
Yeah.
So yeah, the author of this book screwed up the science.
Yeah.
Because that's how hard science is.
Yeah. But the thing is, none of us are going to be able to understand like quantum physics or string theory or any of these things. We just have to take other people's word for it. And basically a scientific paper or any type of approach of someone telling you about science is first and foremost an attempt to persuade you that they're right. It's rhetoric. It's not experiments and testability and things like that. It's a story. And it's a story that a lot of people don't like. They question, they're not sure if they trust it. I'm going to wrap up because we have gone way over time. The last thing I'm going to say is talk about the experience of becoming a flat earther. We looked at how the methodology of how people do that. So it's YouTube, intrigue, attempts to debunk, and then eventually becoming convinced. But that only covers like the technical steps. What is it actually like to become a flat earther? And I want to end with this because I think it's important to understand that we often forget that these are people just like us. It's really easy to just poke fun and call them names and stuff like that. And I think it's because we don't necessarily relate to them. And so in a lot of the studies I looked at, they've interviewed these flat earthers and they talk about their experience that come into it. And the experience sort of comes into three main categories, somewhat ironically, counterintuitive categories. So first you have basically, it's kind of like becoming religious. It's also like becoming an atheist. And it's also like coming out as gay or trans or something like that. So on the religious side, you suddenly have a belief system where you have purpose and meaning in the world. You are important. You've found significance. There is a force out there that clearly cares about you and has constructed the world with you in mind. And while you might not know what that purpose and meaning is, it's there. It is something you 100% know you have. So in that regard, people who become flat earthers, they have all the experience of joining a religion and all of that. Likewise, they have the experience of becoming an atheist. Both me and Sam went through this. We both started out as religious and then became atheists. And when you lose your religious faith, it often comes with a lot of anger, a lot of, why was I lied to? All my life, these people I care about, all these authority figures, all that, they've all been lying to me. And it drives you to research more. You throw yourself into the subject. You look at all these other things. You're desperate to find out what else people could be lying about. Where else are you being deceived? And you also feel the urge to debate and argue this with other people. You see other people, maybe friends, maybe people online. It often tends to be people online because it's easier to argue with anonymous people. But you see these people and you see them telling the lies, the things you now know are lies. And there's a part of you which is desperate to tell them the truth, draw them out of this web of lies. But there's also the part of you that sees them as doing harm and you want to stop them. And so you fight against that. You try to show them the truth and try to show that these are lies. So there's a massive aspect of that to flat eartherism. Lastly, there's the coming out aspect of it, because there is very much, in many cases, a social cost with this. When people tell their friends and family that they believe the earth is flat, it's not a zero risk game. A lot of people lose friends. A lot of people have relationships cut off because of this. Sometimes people are accepting, but you see lots and lots of stories of people who have been cut off from others, have, suffered the social thing of saying, I am different to how you thought I was. But there's also the aspect of being true to yourself. This is an important aspect of their personality, of who they are. And it would be wrong for them to hide it. So they share it with people. They come out to the community as a whole, often knowing the risks, and they try to commit to this new identity. And I think if we try to keep these things in mind, that a lot of us know what it's like to become religious, to have the experience of gaining a religion. A lot of us know what it's like to become an atheist and the feelings that engenders in us. And a lot of people know what it's like to tell people they love and care about that some aspect of them is different to how they always thought it would be. And these are things that I think we should all try and keep in mind. When you're dealing with a flat earther, try to keep in mind what about their experience is similar to your experience. It is hard when you're talking to people on YouTube not to just let the anonymity make you a harsher, more critical, insulting person. I know I've done in the past, especially when I first became an atheist, I've had my fair share of insulting arguments in the YouTube comment sections. I try very hard these days to always be polite, try to see the other person's argument as best as I can, try to put myself in their position and take it from there. And that's actually what I'd like to ask people watching this to try and do. There are some very entertaining YouTube channels out there where basically all they do is make fun of flat earthers. I'm not going to deny that I watch those and I enjoy them. There is, I enjoy them on one part because they are actually quite educational. If you don't know how we know the earth is a globe, there are some good channels out there. I've linked to some in the description again. But yeah, just try to remember these people are coming at things from a slightly different position to you. They are trying to approach these questions as rationally as they can. They've maybe got a bit skewed off in the best way to do that, but they are asking the right questions. They are trying to do that.
I was going to say, and that getting hostility from the globe earth community, but acceptance from the flat earth community is not going to bring them back round to the truth. It's only going to drive them further away.
Yeah, exactly. If you've found a community that agrees with you and makes you feel welcome, especially if you have gone through this situation of being rejected by people you care about, it's very hard to sort of not want to stay with that, not feel the rejection. And as I said at the beginning, people who do even the smallest thing to make flat earth look bad often get, they're not real flat earthers, they're not part of our community anymore. And so there is definitely an incentive to stay in it. But I'm going to end there. I could waffle on about this sort of topic, unless you guys have any questions, unless anybody in the chat has questions.
No.
There was one thing, it's not so much a question, but one thing that I came across during my prep for this that I suppose we haven't touched on. That ultimately, pretty much every version of Flat Earth requires that there is a incredibly powerful body responsible for promoting the globe Earth model, some of whom have control over the ice wall at the edge of the disk world and so on. One of the things that maybe rarely is put up is, how can this body be so powerful that they can control all space, all air travel, that they can hide this from anyone who could possibly understand it, and yet not powerful enough to remove a video from YouTube or Facebook?
I think some of the responses you get to that is they do. That obviously, as we discussed, it's harder to find YouTube videos of pro flat Earth, meaning
non-existent.
Yeah, exactly. I think you've got a very good point. I'm just trying to play flat Earthers advocate, and I do think there are arguments against it. It's that they are hiding these things, but also there's the fact that people will say, well, we've had thousands of years of making flat Earth look foolish. You know, people joke about the flat Earth. There's this idea of ships sailing off of it, and there's all this controlled opposition and, you know, putting this stupid idea of the flat Earth in people's mind, which doesn't represent the real flat Earth. And so when people mention the flat Earth, they're immediately dismissed. So these powerful people have already done the work. They've already seeded that doubt. And it's only, you know, the people who are willing to push forwards and look at where the evidence really lies who find the truth. Something
I've always wondered about this conspiracy to conceal the flat Earth. How big is this conspiracy? How many people are involved?
But on that, like there's I know there's been research into like how long it should take before conspiracies are revealed. Like the number of people, the more people are involved, the more likely it is that, that someone is going to make a mistake or someone is going to blow the whistle or so on. And I think the consensus is that if the moon landings had been fake, it would have taken less than 3 years for it to have broken down. Someone would have made a mistake. Someone would have seen the recording studio or would have come forward.
And you
would need at least as many people surely on flat Earth. If
the
not
thing
more.
with the flat Earth,
the flat Earth, you've got both sides of every conflict on history have known the truth.
Yes, you also
the Russians and Americans in the height of the Cold War both knew the truth and kept it secret.
You also have the aspect that flat Earth is not just a single conspiracy theory, because you have to have things like the moon landings being fake. So if you take into account that the truth about the moon landings would have come out in, what was it, you said like 3 weeks or something like that, but put that on top of the Earth being flat, you can, let's say we double the number of people who need to know. And so you reduce it down to 1.5 weeks. And the fact that the flat Earth is such a bigger thing. Flat Earthers, as I've said before, go on at how easy it is to do these experiments. You can go, they talk about the experiments they do in the gardens, and you go to the beach and you take a picture of the horizon, and you know, you see a ship go over the horizon, which it never does, and you zoom back in and, oh, look, it's there. It proves it's not. If these things were that easy to do, then the ability to keep the conspiracy going just falls apart even quicker. If every geologist or physicist or whatever,
every ship's captain,
airline pilot,
Michael Palin must be in on this.
Oh yeah, but so if you're a kid who's watched, let's say you're a kid who's watched Star Wars and you want to be an astronaut, and you go to university and you study physics and stuff, and then
that's the other thing I was wondering. At what point do they tell you? At what point are you brought into the conspiracy?
And you go
and you go back and retrain.
Well, okay, I've just wasted my entire life chasing this dream, but whatevs. You know, it doesn't work out. It doesn't work out. It's not. You have to think about the people who would be affected by the conspiracy but not be part of it, and they would still have to keep the secret.
So yeah, my father does ocean navigation. And he says he takes the Earth's curvature into account when he's doing this. Is he in on it?
Or has he been fooled and he doesn't actually take the Earth's curvature into account? He just thinks he does. It becomes ridiculous so quickly.
I think that's a good place to leave it.
Thank you very much.
Well, I was going to say thank you, Andrew. And what I love is what you said about how we should think about people who believe in a flat Earth. When, we very deliberately, when we describe what we do with the Cambridge Skeptics, we say we promote positive skepticism. And if anyone ever wants to know what that is, go rewind, replay that part of the video where Andrew talks about how we should think about and treat people who have flat Earth beliefs. That is the summary of what positive skepticism means to us. So thank you so much. That was awesome.
Cool, thank you.
Sam, what are we doing in 2 weeks' time?
In 2 weeks' time, we are looking at personality types, chiefly among those the Myers-Briggs test, and how it's a load of bunkum.
Ooh, I can't wait to talk to you guys then. It's going to be awesome. In the meantime, if you've been listening to this and you have ideas for topics you'd like us to cover in future, maybe revisit some of the topics we didn't get to discuss within Flat Earth, maybe it's something else, leave us a comment on the video or on our Facebook channel or on Twitter. We'll be there, and we can't wait to see you next time. That's it. Bye, guys.
Bye.